All right, so today we're doing dividing polynomials, which is also like long division. So we're going to start with the basic question of 17 divided by 4. So that's really what we're doing. And we're going to set it up like you did in grade 5 or something like that. So your first question is, you ask yourself, how many times does 4 go into 17? That is right. 4 is the answer. Then you multiply 4 times 4 gives you 16, and you subtract 17 minus 16 to get 1 as a remainder. I will repeat it again. You ask yourself, how many times does 4 go into 17? And that's right, the answer is 4. Then you are going to multiply 4 times 4 is 16. Check. And then you subtract to get the remainder. 17 minus 16 is 1. And that is your remainder. I will not repeat it again. All right. We have two ways of showing our division statement with polynomials. I'm just going to speed this up. So we have a divisor times the quotient plus the remainder is equal to the dividend. So dividend is what we start with. Divisor is what we divide by. So that's going to be probably a binomial or a trinomial. Maybe we'll try a trinomial. And then remainder is what we get in the end. Sometimes we're not going to get a remainder, so that's good. But sometimes you will. Second way of showing it is dividend over the divisor is equal to the quotient plus remainder divided by the divisor. Now it'll make more sense once we actually do the example, which is example 1. So, did you guys copy this? I'm going to wait for you to copy this. Okay, we're going to set this up like the long division in grade 5. So we're going to write x squared plus 3x minus 28. That's our dividend. And then we're going to use x plus 5 on the outside. Everyone's good so far? Okay, so the first question is you're going to focus on just x in the front here. And you're going to ask yourself, how many times does x go into x squared? It actually goes x times. Because x by x will give you x squared. So that's what happens when you have polynomial division. You actually have variables involved. Yeah, you're going to try and write the x above the 3x so that it keeps in line, and we're going to present it that way in the future as well. Then the second step is the same as with 17 divided by 4. You're going to multiply x times x plus 5, the whole thing. So x times x is going to be x squared down under here. And then x times 5 is going to be 5x. Good so far? All right. Next step, we're going to do what? That's right. We're going to subtract. X squared minus x squared is what? 0. That's right. And then 3x minus 5x is going to give you what? Minus 2x. And that's pretty much the whole process. You just have to repeat it a few times. So now we're going to drop the 28. So we're going to take the 28, we're going to drop it down, minus 28, and we're going to repeat the process. So we're going to ask ourselves, well, how many times does x go into negative 2x? Negative 2 times, so minus 2. And then we repeat the multiplication. So we're going to take negative 2 times x, which is negative 2x, and negative 2 times 5, which is negative 10. There we go. So what do we do next? Subtract. Now, a problem arises sometimes where people don't keep track of signs. So when you're subtracting, you're actually subtracting this whole thing. So there's a minus in front. So it's negative 2x minus negative 2x, which is 0, right? That's the whole point. We want to make that disappear. We want to make it cancel out. And then negative 28 minus negative 10 is actually negative 28 plus 10, which is negative 18. And that's it. We can't really do anything with this anymore. There's nothing to drop down, and that's your solution. So your answer to the question is, if you divide x squared plus 3x minus 28 by x plus 5, your answer is x minus 2 with a remainder of negative 18. Yeah? What do you mean? We're just carrying 5 along. So here we multiplied it with 5. We had x times x, which is x squared, x times 5, which is 5x. And then for the second one, we did negative 2 times x, which is negative 2x, and negative 2 times 5, which is negative 10. So we focus on that first term, which is x in this case, but we carry everything along after that. And I should put a bracket around this because we subtracted this whole thing too. This 3x? What about it? Well, it was a part of that first step. So because you included the 5, it lined up with the 3x. So when you subtracted it, you got negative 2x. You canceled out the first term. That's the whole point. You want to cancel out the first term, or maybe 2 terms at a time, if it's possible. But in this case, we just canceled out the first term and first term again, and we just ended up with this in the end. And it'll work like that. You'll have like this staircase calculation all the way down. Now this is obviously a quadratic and a binomial, but you guys are going to be dealing with something like to the power of 6, something like that. Because we have to factor those things and then graph them. That's the whole point, actually. Yeah. Now we're going to write this in this form, in the division statement form. So we can write it 2 ways. So you have a divisor times the quotient plus the remainder is equal to the dividend. So in this case, your divisor is x plus 5, times the quotient. What's the quotient? X minus 2. And then plus the remainder, but because it's a negative 18, it's going to be actually minus 18. And that is all equal to x squared plus 3x minus 28. Good? This one kind of makes sense logically. Almost. You get the factor form where you don't have the remainder. And that's going to be our goal in the future. We're going to factor by using this. The second one, question, yeah? This is just your division statement. So if you have an answer, it might ask you for a division statement, and this is what you're going to write. Either this or the second form, which we're going to write next. So you're either going to write first or second. I don't really mind, whichever one you want. Just like that, and that's your answer. Yeah. So the next one is you have the dividend, which is x squared plus 3x minus 28 over the divisor, which is x plus 5. And that's going to be equal to x minus 2 plus negative 18 in this case over x plus 5. Now obviously we would combine this into x minus 2 minus 18 over x plus 5. So just combine those two signs. And that's it. That's pretty much the whole lesson, basically. But we have to do some more examples that are going to get a little bit more complicated. No, there's another example that's missing some terms. And when you're doing long division, you have to replace those terms with 0x. Remember I mentioned that at the beginning? Anyways, let's pause this. All right, that works. We're back. So the whole point of this long division is that we get cases where you don't get a remainder anymore, so where you get a remainder of 0. So if you have a polynomial that divides evenly into another polynomial, you will get a remainder of 0, which means that that's a factored form. So we're going to try that with this second example, and we're going to set it up the same way as last time, but the different thing here is that you have x to the power 3 minus 7x minus 6. You're missing that squared, x squared. You have to replace it with 0x squared. So really what you have is x to the power 3 minus 0x squared minus 7x minus 6. This is what you're going to use. If you don't use this, things are not going to work out as well. So you'll have to apply this every time from now on. Question? Yes? Yeah, if it doesn't have any of the variables of the powers, you have to replace them with 0x. 0x squared, 0x to the power 3. Whatever you're missing, you put it in there, and then you can do the long division. Yeah? See how the x squared is not in this original polynomial? So whatever's missing, you're going to replace it with 0x to the power of whatever you're missing. Because we need to fill that in so that we can... All three of them, yeah. So x to the power 6, x to the power 5, x to the power 4, yeah. Now, if you can factor it without using this long division, you can do it. Just like basic factoring, see if you have, you know, something in common like x to the power of 2 and then factor that out in front and then do that factoring. But if not, you got to do this whole thing. So we're going to take x to the power 3 minus 0x squared minus 7x minus 6. And we're dividing that by x plus 1. So the first question, how many times is x going to x to the power 3? X to the power 2. And just write it above the x squared in the original polynomial there. And then we're going to multiply. So x squared times x here is going to be x to the power 3. And x squared times 1 is going to be plus x squared. There we go. Is everyone good with that? Which part? We're taking this and we're going to multiply it with both of these terms to get the term down here. Once we have that, we're going to subtract. Subtract this whole thing. So what that means, we're going to take x to the power 3 minus x to the power 3, which is going to give you 0. Yeah. And that's our whole goal. We want to get rid of that first term at least. And then you have negative 0x squared minus x squared, which is minus x squared, yeah. Because we're subtracting, you having negative 0x squared. Oh, why is this one? Actually, I don't know why I put the minus. It can be plus. Yeah, it doesn't really matter. Yeah, yeah. I don't know why I put minus there. In any case, you're going to have 0x squared minus positive x squared, which is going to give you a negative x squared. Once you reach this point, you just start dropping other terms. So we're going to drop negative 7x, and we're going to repeat this step. So you ask yourself, how many times is x going to negative x squared? Negative x, that's right. Now it's going to go right above there. And then you repeat the multiplication. So we're going to take the negative x, and we're going to multiply it with both of these. So negative x times x is negative x squared. Negative x times 1 is going to be just negative x. Good-ish, yeah. And then you subtract again. So it's going to be minus. So that's negative x squared minus negative x squared is just going to be 0. So that's gone. And negative 7x minus negative x is actually, I'll write it here, negative 7x plus x, which is just negative 6x. We might run out of space. Then you drop the next one down, negative 6. So negative 6 here. And we go through the step again. So how many times does x go into negative 6x? Negative 6, yeah. That's our last one. And then we're going to do our multiplication again. Take negative 6, multiply everything here, which gives you negative 6 times x is negative 6x, and negative 6 times 1, which gives you negative 6. And yeah, if you subtract this whole thing, you get a 0 down here. And that's it. That's the whole goal of this, yeah. Up top, that's our answer. So now we're going to write it as a division statement. And I'm going to use the simpler division statement. So I'm going to write that our original big polynomial, so x to the power 3 minus 7x minus 6, is equal to our answer, x squared minus x minus 6 times x plus 1. Does that make sense? Now I'm going to take it a step further, just go all the way to the factored form. Can we factor x squared minus x minus 6? It's quadratic. What can you factor it into? It's one of those basic simple ones. X plus 2 and x. Do you guys remember how to do this? Is it x minus 3? All right. And then the last one is x plus 1. So what we did here is we converted this original polynomial into its factored form. And now we could actually graph it, because you know how to graph from factored form. Can you even see through me? No. Okay. I'll back up. And we're back again. So whatever you get after this long division, you could say that they're factors of the original function. So in this case, x plus 1 and x squared minus x minus 6 are factors of x to the power 3 minus 7x minus 6. We went further and got the factors of x squared minus x minus 6. So we fully factored this polynomial. And that's it. It must be lunch because I just wrapped this up.